Hey everyone. We are continuing on with our notes. We're going to pick up for 13.5, example 6. It's on page 6 of your notes. So you're going to need to recall your properties of logarithms for this next part that we're going to cover. You have your product property, which says if you have a product of log of base a of x times y, you can write that as the sum of two logarithms, log of base a of x plus log of base a of y. So that's the product property. The quotient property says that if you have a quotient inside here, the log of base a of x divided by y, you can split that up and write the log base a of x minus log base a of y. And then the power property allows you to bring, if you have a logarithm base a of x to the power of r, you can bring that r down in front. And all of these properties can go in reverse as well. It depends on if you're expanding or if you are condensing a logarithm. So let's move on to example 6. And we did several of these with logarithms of base 10 and other bases as well. So if you need to look back in your notes or look at some of those examples, that might help as well. Remember, we have ln, which has base e. It's not going to be written there, so you just need to know that. And so when you have a logarithm, a natural logarithm, the same properties are going to hold. So we're going to expand this ln of, we have a product in here, so it's 6 times e to the 5t. So when I expand this, I can write it out as ln of 6 plus ln, and that's how you say it. Instead of saying the whole thing, natural log of 6, we say ln of 6, and plus ln of e to the 5t. So that's using the product property, but we can still expand this even further using the power property, because you have a power of 5t. So think about what you can do with that exponent, and you hopefully are recalling that you can drop that down in front and be 5t times ln of e. And then it says here, let's simplify that result. Well, the natural log of 6, we can't really simplify unless we grab a calculator and get an approximate value for the natural log of 6. What does that mean, by the way, the natural log of 6? The natural log of 6 is trying to figure out e to what power is equal to 6. So you need a calculator to do that. And on your calculator, the ln button, I think we went over that last video, ln is right below the log button, and it has base e. So your calculator can only deal with two bases, base 10, which is called a common logarithm, and base e, which is the natural logarithm. So ln of 6 doesn't simplify at all. So this is going to stay ln of 6, and then plus we have 5t, and ln of e, what is that? Well, the base is e, so when we're finding ln of e, we're finding e to what power equals e, and it would be e to the first. So ln of e is equal to 1, so it's times 1, which doesn't change anything. So the completely simplified result would be ln of 6 plus 5t. And so we're going to do this, nope, example 7 is a little bit different. We're going to solve for x. So what we can do is we can first of all think about what the base is for both sides here. We have ln of x and ln of 8 over here. Those are both base e. So I can't really do much with ln of x right now, so I'm going to leave that side alone. But I can bring this negative 3 back up into the exponent. So it's the power rule, but bringing the exponent back up instead of bringing it down in front. So this is the same thing as ln of 8 to the negative 3rd power. Now I want you to think about this. If the natural log of x is equivalent to natural log of 8 to the negative 3rd power, what do you know about x and 8 to the negative 3rd power? If the two natural log, if they're equal to each other, that means that these arguments must be equal to each other. Now that's solving for x, but it's not simplified. How do you think about how you can evaluate 8 to the negative third power and simplify that? You need to get the exponent positive, so we have to drop it down into the denominator, and it becomes 1 over 8 to the third, which is, you can go ahead and grab a calculator. 8 to the third power is 64 times 8, and I have a dead calculator. Un momento. Okay, so you should get 8, I could do it on the board, but 512. So 1 divided by 512 is your final simplified version there. All right, example 8. We're simplifying the natural log, which again has a base e, and we don't write it there, but you need to just kind of know it's there, and if it helps you to write it there, you can feel free to go ahead and do that, but you're not going to put it in as part of your answer in the end. Like, you want to make sure that you don't put the e there when you're simplifying. So we can use the power rule, power property, and bring the 15 down in front. So we have 15 and then times ln of e, and we've gone through this a couple times. Ln of e is equal to 1. I'm going to go through the reasoning of it again, just so hopefully it's going to stick into your brain. You've got a base of e, so e to what power is equal to e? And that would be e to the first that equals e. So ln of e is 1, so I have 15 times 1, which simplifies to just 15. There were other other properties that we looked at as well throughout some of the previous lessons, so you can use different methods for simplifying number 8. Okay, so go ahead, pause the video, try to do example 9, and then come back and we will go through it together. You can check your answer and I'll go through it here. So I have ln, I'm going to use the product property because I have 10 times that. So ln of 10 plus ln of e to the 4t. Well, ln of 10 is e to the what power equals 10. I can't simplify that. I can bring the 4t down in front, however, and that is a step in problem solving that you're going to see if you get to the point where you're solving for exponents. But we're not doing that in this lesson. Okay, remember ln of e is 1, so when I multiply by 1, I really don't even need to write it, so this would simplify to ln of 10 plus 4t. Okay, example 10, we did a problem just like this, but with a common logarithm, which has base 10. We're going to do one with natural log. So if the natural log of 3 equals, we're given that, is equal to 1.0986. Natural log of 5 is equal to 1.6094. Natural log of 9 is 2.1972. Find each of the following. So what we want to do is we want to use the facts that are given to us, and we're going to find the natural log of 45. But what you want to make sure that you're doing is you're going to look at, like, 45 is how can we get 45 from the information given? Well, we can, if we multiply 9 times 5, that's equal to 45. So we can split this up into the natural log of 9 plus the natural log of 5 using our product property, and the natural log of 9 is given to us, 2.1972, so right here, plus ln of 5, which is given to us here, 1.6094, and you'd simply add those two together to get your final result. And I'm just going to use a calculator. 2.1972 plus 1.6094. If you're doing this without a calculator, just make sure you remember to line up your decimal. 3.8066. Natural log of 27, You can rewrite 27 in terms of what we're given as 9 times 3. So go ahead and complete that using the product property, and then come back, and I'm going to do the problem as well. I'm going to do the quotient property here. So I have ln of 1 minus ln of 9. See if you can figure that one out, and check your answers here in a minute. Okay, for part B, I got 3.2958. If you're not getting that, make sure you write this down, and you can ask me during class. And then for part C, I got negative 2.1972. Recall that ln of 1 is 0. All right, so again, go ahead, pause the video, and read through this problem. We have so that you understand what it is we're trying to find and all that, and then see if you can do it on your own. And I'm going to go through it right here, right now, but you should try to do it on your own first. So the annual rate of depreciation R on a car that's purchased for P dollars. So pay attention to what we're talking about. So the annual rate of depreciation is the R. It's purchased for P dollars, and it's worth W dollars T years later. There's a formula given to you here. And so there's a lot of different formulas that involve logarithms, and so I can't go through all the different applications. So you're going to want to look at your, whatever the application is that you're given, look at the equation, figure out what all the variables represent, and then try to plug in what you know and then solve for what you need to find. We need to find the annual rate of depreciation. So we're going to be finding this R value on a car that is purchased for $1,200. So it's purchased for $1,200. That's going to go in for P. And sold 6 years later. It's going in for T for $3,000. So that's what the car is worth T years later. We need to solve for R. So you guys go ahead and set up the equation. You should get log of 1 minus R equals 1/6 log of 3,000 over 12,000. And that becomes 1/4 over here. Now, to solve this, I have R stuck inside this logarithm. So I'm going to simplify the right side first. One of the things I can do is I can bring the 1/6 back up top. And I get log of 1/4, because that's what 3,000 over 12,000 simplifies to the 1/6 power. And now I have, this is just a number. And I could actually put that in the calculator because its base is 10, because there's no base written there. And over here the base is 10 as well. I'm just going to leave it in this form, and then I'll put it in the calculator in a minute. But I'm going to rewrite this. So I'm solving for a logarithm. So simplify things first, and then rewrite in exponential form. So we're going to take the base 10. Remember, the logarithm equals the exponent. So this is going to be my exponent. And it's equal to 1 minus R. So now if you recall, if this is base 10 and this is a base 10, they are inverse operations of each other and they cancel each other out. So what you're left with is 1/4 to the 1/6 power. And that equals 1 minus R. So I want to get R by itself, and I could put this in the calculator now, or I can put it in at the end, which is what I'm going to do. To solve this for R, I need to subtract 1 from both sides. So I have 1/4 to the 1/6 power minus 1 equals negative R. To get rid of the negative, so it's just R by itself, I'm going to multiply both sides, or you can think of it as dividing both sides by a -1. And when I divide by a -1, what it does is it changes the signs on everything. So I have a -1/4 to the 1/6 plus 1 equals R. And now I'm going to put that in the calculator. Okay, so we're going to type in to the calculator -1/4 in parentheses to the 1/6 power plus 1, and we'll get our R value. So we're going to do a negative key, and then we're going to type in 1 divided by 4 to get the 1/4. And then we have to raise that to the 1/6 power. So 1, raise it to the 1/6, end your parentheses, and then I have to add 1, and I get R equals 0.206, which means that R is equal to, this is a decimal, so to turn it into percent, we need to move the decimal over 2 places and you would get 20.6%. And that is the annual rate of depreciation for that car. All right, that's it.